Was I'm
This
sitting in the
meeting is
library.
being recorded.
Yes. This is the recording, and then we will share. Let me share the screen. Yes. Now you will be able to see my screen. Yeah. This is the very first material that you have shared with me. Uh, we are on page 50. Yes. Uh, Virendra, today, could you read well, Amma? What did you study today? What is the topic that you studied?
Organometallic chemistry previous year questions I solved, sir.
Yes, very good. Yeah,
Topic wise manner.
yes. Previous question papers with questions and answers were there in the Himalaya publishers. Okay, ma? That question, answer, 2 marks questions, 4 marks questions, all those things. You should put it in writing. Okay. Like mathematics, chemistry too is a very special subject. We think we understood very well. We think we can reproduce very well once we study chemistry. But particularly when there are any equations, when there are any equilibria, when there are schemes, organic schemes, when there are any diagrams, for example, organometallic compounds, for example, structure of inorganic complexes, we need to put it on paper. If we just read from the notebook with our eyes, we think that it is stored in our mind. But literally, when we put it on paper, everything will be blank. So practice. Okay, ma. Once you study a particular organometallic compound, its chemistry, its structure, okay, its properties, reactions. After studying, you should try to write it down on paper without seeing. That is how you will know how much you learned. Okay. Yeah. Here we see hybridization of inorganic molecules. Usually we know sp hybridization, sp2 hybridization, and sp3 hybridization. That is a very well-known hybridization phenomena in organic molecules. Okay, we know alkanes, we know alkenes, we know alkynes. There we come across the concept of hybridization. Then molecular orbital theory, MO theory, and the molecular orbital configuration. Okay, ma. You see molecular orbital diagram. For example, we take oxygen. O, O, O2. So this is the oxygen atom, this is the oxygen atom, this is the oxygen molecule. That is the difference. 2 atoms of oxygen forms a molecule, oxygen. 3 atoms of oxygen forms a molecule, ozone. This is a homonuclear molecule. If we have something like this, what is this?
Heteronuclear.
Yes. Likewise, if we have something like this, heteronuclear. Again, this is homonuclear. Okay, ma'am. From molecular orbital theory, we will try to write the molecular orbital configuration. Electronic configuration, we know. For example, oxygen. Tell me the electronic configuration of oxygen.
1:2:2 before. 2:2 before.
2p.
4.
Why?
Because it oxygen atom consists of 8 electrons in its shell.
Likewise, for molecule also, for oxygen molecule also, we can write the configuration. In total, we have how many electrons?
16.
16 electrons. The 16 electrons should be put in the molecular sigma 1s 2 sigma 1s star to sigma 2s to sigma
Sigma 2
star
to
2s
yes
2. Total how many over? 2, 2, 4, 6, 8 are
8
over. How many are remaining?
8
8 more electrons are remaining. So this is the molecular orbital diagram, Amma. 1s, 1s, 2 electrons, 1, 2, 1, 2. Total 4 electrons will come here. 1, 2, 3, 4. Okay, so this is called sigma 1s. This is called sigma 1s star. This is how we build up the molecular orbital diagram. In our undergraduate studies, we learn about all these molecular orbital diagrams, molecular orbital configuration. Then comes 2s. Okay, 2s. Here, how many electrons are there in the 2s?
4
2 plus 2, 4. Okay, then here. 1, 2, 3, 4. Because first we have to fill this level. This is a degenerate orbital. This
yes
is
sir
degenerate orbital. This is lower energy orbital. This is higher energy orbital. Sigma 1s is of lower energy. Sigma 1s star is higher energy. Sigma 2s is lower energy orbital than sigma 2s star. Sigma 2s star is higher energy orbital. Okay. Sigma 2s star. Okay. Then comes, what is the next level? Sigma 1s, sigma 2s.
2p
Ah, 2p. Thank you. 2p. Okay, here our teachers have thought that s orbital is spherical in shape and s orbital can accommodate 2 electrons. Whereas p orbital is
dump
dumbbell shape and there are 3 p orbitals and each orbital can accommodate 2 electrons. All the 3 p orbitals can accommodate 2 into 3 is equal to 6 electrons. So 3, this is oxygen, this is oxygen, this is oxygen molecule, this is oxygen atom, oxygen atom. Okay, so let us see. Uh, Total how many electrons are there in P? 4.
4
Because you said here 1s2, 2s2, 2p4. So let us fill the 4 electrons. How will you fill the 4 electrons? 1, 2, 3. First of all, each of the degenerate orbitals should be filled with single electron. Pairing of electron takes place only after each of the
filling
orbitals are half filled.
yes
We
sir
know these rules of filling the orbitals. Okay, this we have learned in +2. So 1, 2, 3. The fourth electron will again come to px. Okay,
ax
here also we have 4 electrons. This side also 4, this side also 4. So come to the second oxygen atom and fill all 4 electrons. How will you fill the 4 electrons? You should not fill 1, 2, 3, 4. This is wrong. Okay, what is
yes
wrong
sir
with this? Unless all the 3 energy levels are half filled, pairing of electrons will
should
not
not be
take place. Unless the girl is 18, unless the boy is 21, pairing forbidden. Beautiful chemistry, chemistry is like the beautiful relationship between young boy and young girl. So pairing will take place only when all the 3 degenerate orbitals are exactly half filled. So
by Hund's rule sir
what is that
Hund's
rule?
rule Hund's rule
Thank you, thank you. Most of the names I forgot, most of the fundamentals of chemistry, but these are imbibed in something, okay, in our, what to say, in our DNA, they are already there. So I will not forget all these fundamentals. So the pairing will happen like this. These are the beautiful molecular orbital diagrams my BSc teacher has taught. While I was doing my BSc in Government Arts and Science College in Rajahmundry, I used to have very nice teachers like you. When I saw you near the board, I remember my chemistry teachers. I am very much happy, Virendra. The problem with today's youngsters is today they will attend the class, tomorrow they will not come. I saw the students like that. I used to have some Muslim boys. They are very good. Ibrahim and Ahmad, they are very good. They are very nice students, but they wanted leave on Sunday. I said, only if you have good marks in the class, you will be given Sunday leave. If you are not having good marks in class, I will not give leave on Sunday. Sunday too, you should come. The boys got hurt and probably, yeah, they're very good boys. Ahmad and Ibrahim, I used to teach two boys. I love teaching. Later on, what has happened, I moved to Vadodara, JSFC University, so I have to discontinue the students. But for that, they attended regularly. Even after my travel to GSFC Vadodara, I was teaching them online like this. They're very, very receptive students. I taught them in their 9th and 10th standards, and now they are in their 12th and graduation, BSc. Yeah. So let us fill the 8 electrons. Okay, ma? Chemistry is so beautiful, ama. It all depends on the teacher, how the teacher teaches. Okay. Uh, 1, 2, 3, 4. So here 4, here 4. Total we have 8 electrons. Okay. Then let us see how will we fill. Here we have 2px, 2py, 2pz. Okay. So how to fill? Sigma 2p, sigma, it's quite old. What are the energy levels? Sigma 2px, 2py, pi 2px, pi 2px, pi 2px, sigma 2py, sigma 2pz. How will be the electronic or how will be the electronic arrangement will be? Do you remember something? The distribution of
First sigma star,
ah ah
next pi
yes
star.
sigma star and pi star. Okay,
Hmm.
no problem. This is the problem. Even for an expert teacher, if you see, I'm teaching this after quite, I thought extensively this while I was a BSc student. When I studied my BSc, I studied my BSc in 1997 to 2000. Gone are old days. Let me come quickly. Molecular orbital of diagram of oxygen. Okay. Yes. Here we can see the beautiful. Yes, this is what I'm telling. Yeah. Pi to px, pi to py, sigma to pz, and sigma to pz, sigma to pz star, pi to px, pi to py, pi to px. Yes, this is what exactly I wanted. This is the distribution of molecular orbitals. Here the distribution or the order of orbitals is like this. Ah, Here, sigma 2p z, z orbital, sigma 2p z, and then
Pi
pi
2px,
2px,
pi 2py.
ah, pi 2p
Y.
y. So, likewise, pi
Star
2py
2px,
2p pi 2p x star
star, pi 2py star.
pi 2py star and sigma 2pz star. Okay, ma. Star will be here. Okay, pi 2px, pi 2py, pi 2px star, pi 2py star, pi
Sigma 2pz star will not be there, sir.
ah yeah, it will be. Let us fill the electrons and see. Let us fill the electrons and see. Total how many? 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. You are correct. Because pi 2py star and pi 2px and pi 2py star has two unpaired electrons. Two px, two py, two pz. Okay, 4, 1, 2, 3, 4. 1, 2, 3, 4. Then sigma 2p z pi 2p x pi 2p y
Pi
pi
star.
pi 2p x star.
Pi 2py star.
Yes, pi 2p y star. So in total we have 4 plus 4, 8 electrons. 1, 2, again 3 here, 4 here, because these two are degenerate orbitals. These two have same energy, so they need to be half filled first. So 1, 2, 3, 4, 5, 6. 6 electrons are over. How many electrons are remaining? 2 more electrons. 2 more electrons. We cannot fill all the 2 electrons in pi star 2px. because pi star 2px and pi star 2py are again degenerate energy levels. They have same equal energy. First of all, equal energy should be half filled. Then only pairing takes place. So, what will happen is the two electrons, one will be in pi 2p x star and other is in pi 2py star. So these are called unpaired electrons. What are they called? Unpaired electrons. That is why oxygen is called paramagnetic in nature. Okay. Uh, for example, if we were asked to draw a uh, molecular orbital configuration, this is how we have to write. Emma, how the configuration looks like? Sigma 1s power 2, sigma 1s star
Uh,
2,
two-
sigma 2s
2s
2, sigma
sigma 2
2s
star
star 2, then
sigma 2z
sigma 2pz 2,
pi 2px
pi 2px 2,
pi
pi
2py
2py 2, then
star
pi
2px
star, pi star
2px
2px
pi star 2py
1, pi star
2py
2py 1.
sigma star 2pz.
This is what is called the molecular orbital configuration of
Energy.
a homonuclear oxygen atom. Emma, this is one example. We will discuss more. This is just brushing up of our fundamentals. Okay, ma. Then, what I mean to say, Virendra, you are a very good teacher, Amma, no doubt about that. Even a very good teacher needs revision.
Yes, sir.
You are a diamond, but even a diamond, if it is not polished, it will
It
not
can't shine.
have the brightness. It's
Yes,
of no
sir.
use. It will be like any other stone. So, I thought many BSc graduate students, all these things. You see, even I do not recapitulate very quickly because it's almost 97. I did this 97 and 98 means how many years have gone? 2000,
27, sir.
15 plus 2000, 25 plus 28 years. Almost 28 years. I don't. In research, where I will use this? Tell me.
Yes, sir.
If at all I use something, it's very different. Okay. Let's because we do research at a different level now. Molecular orbital theory, term symbols, and electronic spectra of diatomic molecules, atomic spectroscopy. What is atomic spectroscopy?
Atomic spectroscopy, sir. Uh, I think
Electronic spectroscopy, we
interaction
know.
of
What is atomic spectroscopy?
interaction of electromagnetic radiation with atoms, sir. It
Elec-
deals
Interaction of electromagnetic radiation with
with atoms.
atoms. Atomic spectroscopy. Even very familiar things, sometimes we get a doubt. Okay, so it's always good to ask the question. Atomic spectroscopy. What is
It
atomic
depends.
spectroscopy?
Sir, it is atomic spectroscopy. It is based on transition of electrons between discrete atomic energy levels.
Ah, now I understood. Now I understood. Lyman series, Balmer
Hmm.
series. There we get no atomic spectroscopy, Lyman series, Bowman series, all these things we learned a long back. Atomic
It also has
spectroscopy.
two types of spectroscopy,
Ah,
atomic absorption spectroscopy, atomic emission spectroscopy is also there.
atomic emission, atomic absorption. Okay.
Types
AES.
of spectroscopy, sir.
Good. AES. Yeah, yeah. That's what. That's what. Atomic absorption spectroscopy, atomic emission spectroscopy. That's what I meant. Yeah. AAS,
AFS is also there, sir. Atomic fluorescence spectroscopy.
AES, AFS.
Ah, yes, sir.
Yes, very good. Okay, we will deal with that. Isolable species. Okay, what are isolable species? Multiple metal bonds. Higher
Hmm.
boranes. Definitely, there will be at least one question on boranes. Okay, diborane, boric acid, all these things. Boron chemistry, you should deal with very carefully. Amma. The structures of boron compounds, you should write it down. Metalloboranes, carboranes, SN1, SN2 mechanism. SN1 means substitution, nucleophilic, unimolar reactions. SN1, substitution, unimolecular substitution, nucleophilic. N means nucleophilic. Nucleophilic. One means unimolecular. One means
Union
unimolecular
reaction.
reactions. In organic chemistry, we read about SN1 reactions, SN2 reactions, then Cannizzaro reaction, and many other named reactions. We explain in terms of SN1 mechanism, SN2 mechanism. All these things, while I was a BSc student, there used to be a very nice chemistry teacher by name Gumadi Samuel Moses sir. Professor Gumadi Samuel Moses sir has taught me about all these SN1 reactions, SN2 reactions, carbohydrates, amino acids, carbohydrate chemistry. Wonderful. Then I think in that particular year in 1998, I got 88 marks in chemistry out of 100.
That's
Yeah.
nice, sir.
Yeah, yeah. Those days in Andhra University, 88 is very high, Amma. It's not like these days. Nowadays, everybody is scoring 98, 99, 100. These days are different in
But
Vigyan,
in
in
the SV
Narayan.
University, marks are not giving sir.
Ah, in
But
Andhra
in the
University,
SV University, marks are not giving, sir.
yes, yes. Even in Andhra University, Sri Venkateswara University also very strict. Getting
Hmm.
distinction itself is very difficult.
I think 70% is the highest this year.
Yes, acha, acha. Even Andhra
Hmm.
University, it was like that. Getting anything about 75% is very, very, very rare. SN1
Even though we
mechanism.
attempt with the choice questions, also they are not giving complete marks for a student. That
Yes,
is the only
yes,
disappointment in the university. Students failing.
that is there. That is there. In Andhra University too, the evaluation was very, very strict, tough. Substitution unimolecular reactions, substitution bimolecular reactions, lability and inertness. Okay, it's something related to the ligands. Lability, inertness. Then SN1CB, trans effect, OSM. What is OSM and what is ISM? Any
ISM.
answers? Ah,
No, sir, I
what is
have no.
what is OSM? What is OSM? What is ISM?
Order of symmetry, sir.
What is SN1CB? Then, after a long time, I'm seeing the CSIR syllabus also. These days, I did not teach anyone, Amma. Okay, I will be uh, on track and we'll move faster. Huh? Electronic spectra. Electronic spectra means invisible spectroscopy, basic concepts. Here, the basic concept is absorbance is proportional to concentration. Okay. Beer-Lambert's law states that the absorbance is directly proportional to concentration of the analyte microstate selection rules, DD transitions. Okay.
Orgal diagrams.
DD transitions and CT transitions. We have to be very, very careful when we judge the transitions, the kind of transitions, DD transitions and the CT transitions, charge transfer. KMNO4 is there. Okay, KMNO4.
Self indicator.
What is the oxidation state of manganese in KMNO4? 7 plus. Okay. 7 plus means it's manganese is scandium, titanium, vanadium, chromium, manganese, D5 system. Am I correct? Scandium, titanium, vanadium, chromium, manganese. What is the
D5.
oxidation? What is the oxidation state of
+7.
+7? So how will you get the configuration? How will you write the configuration of manganese here?
4:3:5 argon.
Uh,
Argon 4:3:5. What is the question, sir?
yeah, manganese is a D5 system. What is the kind of phenomena responsible for the color? Charge transfer. Charge transfer phenomena, correct?
Yes, sir.
Charge transfer from oxygen to metal. There should be almost KMnO4.
Metal charge transfer.
How the electrons are distributed?
In the KMnO4, O2 minus is there, no sir, MnO4 minus. Oxygen donates electron density to the empty manganese 3D orbital.
Ah,
Oxygen atom
Manganese?
donates its electrons to the manganese atom cell.
yeah. Manganese is Mn7 plus. Mn2
O4 minus.
plus. Okay, Mn2 plus is D5 system. Okay. Mn7 plus is D0 system.
Yes, sir.
So, in Mn7 plus, there are no D electrons, no DD transitions because there are no D electrons. So, why do we see purple color in KMnO4?
Charge transfer transitions.
From
Ligand to metal.
what is the ligand? Oxygen.
Oxygen.
It is
Metal is
it is because of the charge transfer from
Ligand
Virendra to me. I am manganese.
Yes,
You are oxygen. Because of the charge transfer from oxygen to manganese, we are seeing the color in potassium permanganate. Because you see, I showed you. In potassium permanganate, the manganese is in +2 oxidations, +7 oxidation state. D5 system with Mn2 plus is D5. Mn7 plus is D0.
Zero.
So there are no DD transitions. The reason for the purple color is charge transfer from oxygen to metal. These are the very fundamentals of what is charge transfer, what is DD transfer. We will read more about these things. We already discussed about D block elements and F block elements. Acids and bases we discussed. Molecular symmetry and group theory and nuclear chemistry. And then spectroscopy, EPR, molecular energies, classification of spectra, representation of spectra, selection rules, intensities of spectral lines, absorption and emission spectra, microwave spectroscopy, infrared spectroscopy, Raman spectroscopy, NMR spectroscopy, mass spectroscopy, UV EPR, mass wire, and then atomic spectroscopy. So we are running short of time. I will close at this point of time, Amma. We will close because in 5 more minutes the library will be closed. We'll take up the class tomorrow. Tomorrow,
Yes.
11 o'clock. What I expect is tomorrow you have to read all these things and be thorough. Okay.
Okay.
Now, what are all the topics we have discussed? You should read, and tomorrow I will ask questions on this. Agreed?
Okay, sir.
Tomorrow we because Friday we should complete inorganic chemistry.
Yes, sir.
Agreed? All the best, Amma. Take care.
Sir, any response from Archana ma'am, sir,
Archana,
for
I will
me?
remind Amma. Archana madam, I will remind today. Most probably by tomorrow I'll get. Okay.
Ramesh sir, Rajesh sir.
Rajesh sir too. I could meet Rajesh sir in person today, Amma, but I could not talk about you. Sorry. Because I do not want to talk in front of everyone. Personally, I want to speak. So I will write a message personally to sir.
Okay,
Ah,
sir.
okay. See you, Virendra.
Thank you, sir.